Welcome back to session. Okay. Anyone confirm, please? Are you able to see my screen?
Yes, sir.
Okay. So as I'm explaining the shaft furnace, so basically what will happen, it is in a cylindrical shape of lengthy tube where the material is feeded. In other end, we use coal dust as a fuel to heat up this material. Okay, that is the process in shaft furnaces. Okay, let us. So now we'll see what are the hazards associated with these processes, furnaces, even clean also called as shaft. Both are same. So when we say the main hazards associated with this process will be burns due to contact with hot surfaces, surface in the sense the surfaces of the equipments as well as contact with the metal also or the product which they are manufacturing. And burns due to contact with the hot product, fuel and electricity, splashing or bubbling of molten metal while melting this metal due to the impurities in the metal. There is a chance of bubbling and also sometimes splashing will happen. Sometimes what will happen, especially this scrap, they used to throw this spray bottles, perfume bottles, even small domestic gas cylinders like 5 kg cylinder, 2.5 kg cylinders. Those cylinders also they'll put in the scrap because there is a residue of the gas content in those cylinders, resulting they can blast as well. Then contact with the cooling water with the molten metal or the slag in the induction furnaces, explosion due to sudden steam generation. Sometimes what will happen, to cool these furnaces, around the furnace, we will have the jacket. In that jacket, we used to circulate the water to reduce the temperatures whenever we are not going to use the furnace further. So in case of any damage to that tubes, if the water leakage happens in the furnace, at the high temperatures, the water molecules will divide into O2 and hydrogen. Due to the hydrogen release, it will result in an explosion. Then fire and explosion due to leakage of the fuels. Sometimes fuel leakage also it can cause an explosion and fire. Then carbon monoxide from the fuel gas, also product of combustion. Then explosion due to hydrogen, which is happened due to leakage of water or contact with hot metal. Then the precautions follows good insulation over the hot metal surfaces so that we can avoid the people contact with these surfaces, and protective clothing for head, face, and hands and feet, so where they have major exposure. Then respirators, as we see in IS 102, two types of PPEs, respiratory and non-respiratory. So here we use the respiratory PPEs and the non-respiratory will be covered in point number 2. And respiratory PPEs will be then comma, eyeglasses. This is again non-respiratory, plain or tinted or protection against the dust, fumes, toxic gases, glare, etc. So glare also we have covered. It is in a high intensity of light. It can interrupt our visibility. It is a kind of disturbance. We can't able to see the articles comfortably. A simple example, while you are traveling on a road, people will come in a high beam. Suddenly, if they turn to a high beam, that is in a glare. Then exhaust hoods and also fans to draw the dust and fumes and gases. So basically, they do over the furnace. So they put this exhaust system, how like in IS 102, where we have discussed about local exhaust ventilation system. Exactly over the furnace, they put this exhaust hood so that the instant the fumes or the gas is generated, it will capture and it will take out to the exhaust system. A good ventilation to vent off the hazardous waste generation from the scrap charge and also alloys and fixtures, and hot work permit before working on any worker to enter any hot chambers and ensure the cooling, fresh air ventilation, also lighting necessary. Sometimes they use to work on these furnaces to check the lining of the furnace. So it has to be checked, the condition of the furnace and also the temperature levels. Then interlocking to cut off the fuel supply in case of any flame failures. So sometimes what will happen, the flame gets off, but the fuel it is completely spraying on it. In such case, what will happen? There is a huge dump of fuel, which is unburned fuel will be there. In case of any sudden ignition, it leads to explosion. So it should be having an interlock system so that we can avoid such situations. And also precautions while lighting the fuel, the burner to prevent the flashback and fire and explosion. And training and awareness programs to the workers to handling of this scrap and also the molten metal, especially handling of ladles while pouring in the molds. Then provision of drinking water and also shielding to avoid the heat disasters. Like because of continuous exposure of heat, they'll get dehydrated by losing the water content as a sweat. Then flame-proof electrical fittings with solvent drying ovens and also PPE against the eye and skin irritations, respiratory disorders also will happen. So we have to provide suitable PPEs to the respective operators. And precaution against the free silica, asbestos while cleaning and maintaining the furnaces, area monitoring and also medical surveillance of such hazards and explosives. So silica and asbestos, these are the two dangerous materials which are identified as occupational health diseases. Silica will be especially in the cement manufacturing quarries or any granite manufacturing or polishing industries where the silica exposure. Asbestos, it is completely banned now. Previously, we use mostly this is for roofing sheets, even some of the gloves also for heat resistant gloves as a heat resistant gloves. Okay, that is about the hazards and precautions with respect to the basic metal manufacturing. Now we'll see in foundries how this metal is manufactured or how it is prepared. So basically, this is the structure or process of a steel foundry. So we'll have a pattern shop. Pattern means it is nothing but the desired shape. What shape of what type of shapes you want to create by pouring that molten metal, which means the liquid metal. Then core shop where they use the core making. Core, it is nothing but it is in a cavity. So if you put two parts in between core where you will make the cavity, it is nothing but hollow space. So it will create the desired part which you want. For example, if you take any valve, a small valve, if you see in our home also, the hollow section within the valve, we call it as a core. When I say pattern, the outer part of the valve which you are physically seeing, that is the pattern. Then sand plant, sand preparation. So basically they use sand for creating these patterns where we pour the molten metal to get a desired shape. Once it is done, we'll come to the foundry where we do melting of metal scrap, and then we do mold making, then stripping, knockout, and decoring. So stripping is nothing but stirring of the metals. Casting is nothing but pouring of metal. Once we mold make happens, so pattern will create a mold based on the pattern. It is a masterpiece. When I say pattern, it is a masterpiece. Then we use sand, put the pattern inside. After the pattern, we take out the pattern from the sand. You will create a mold, which is the specimen where we want to get the shape out of it. Then once we pour, pour in the sense you are pouring the material. You are just putting the liquid material into this mold. Then stripping, knockout is nothing but once the molten metal become hardened, so you will take out the complete sand which is adjacent to it. Then decoring. Decoring nothing but the hollow space which is need to be created for a valve. What I can do is just give me a second. I think I can show on a small video so that you can understand better. Because who familiar with this process, they can understand with the presentation. Hope my screen is visible, right?
Yes.
Okay. So you just see this simple process. I will explain without an audio. These are we called as a core box. Whatever there it is there in the applied sand, then we are reaming it. Now it is the cavity. Now they will pour the molten metal from through the risers. Once it is cold, that is the desired part which we required. It is the basic simple process. They have removed the risers, and this is the part which I am looking for. Riser is nothing but where we pour the metal. I think we can see this video as well. So it is in a small process he's doing. these boxes we called as mold boxes to hold the sand which we are applying to it. I have one more, it is very lengthy, but it's not required for us. So when I say pattern, as I mentioned, these are the masterpieces. So the pattern will be only one. Out of this, we'll create n number of parts which we want. So basically, these patterns made in two varieties. One is they'll go with wooden. Sometimes they make these patterns in aluminum as well. These are the most prominently used materials for pattern making. In nowadays, they are using 3D printing patterns also by using 3D printers instead of using wood and sand, because this wood and aluminum takes so much of time and so much of skill which is required to make the patterns precision and also uh, get the accurate quality. So nowadays they're using 3D printers for creating such kind of patterns. So if the two patterns will come together, that is the desired part which we required. These are the core in the sense which will create the hollow space. Yes, this is a completely a hollow section within the part which we are going to manufacture. So he's placing the core, putting sand over it to create a shape of it. The same process happens in a larger section, especially in the industries. There are industries who makes these kind of manufacturing from 50 grams. There are industries who do this process for even 50 tons also. He is making a provision to flow the metal from pouring. Now he is putting the, other part of it. Then he will apply again sand over. Along with the sand, they use some resins to become harden the sand, because alone sand itself it will not create or it will not give any shape. They use some sort of resins like a binder kind of chemical, so it can be able to harden the sand. So there it became a cavity. He removed the pipe. So after settling the complete sand, he will pour the molten metal from that, the provision he has made using that pipe. So that they will pour from one side, sometimes they pour from both sides based on the criticality. Oh, sorry. Sorry, I'm not having the premium version of YouTube. Yeah. Yes. Now he's making a way to run a metal to the cavity. After this, he will take out that wooden piece, that is pattern. We just do ramming so that it can loosen. Simply, he will take it out. Yes, that is the shape which we want. I think he is giving some vents to uh, leave out the gas. During the pouring process, the chemical which is there in the sand, there will be a chance of reaction. So he's creating some provision to take out the gas which is generated. Now he's putting the core. So here I'll take a small pause. So what will happen? The core, in the sense, wherever there is a gap between this core and the sand mold around it, there my metal, the molten metal, it is going to be settled. So that what will happen once I poured, I will take out this core by doing drilling or by chipping out, so that it will create a hollow section inside the part. Then after this, he will put the, I mean, the top portion of the part, so that it will create a complete shape. Yes. He's making some risers to pour the metal instead of directly pouring on the pattern, because that wooden piece or it will get damaged. This is a small scale of furnace. I think he's using gas. This is the complete scrap metal. It looks like aluminum. He's using that scrap metal to melt it, and he will pour. Yeah. This is called ladle in our industrial language. Whatever he has, pouring the metal, the container shape. It is a called as a ladle. So after 15 minutes, cooling, they will take out this core box. Yes. See, that is the desired shape we are looking for. Now you will get it out. So how we can create the gap, because it is poured, it has become a solid block. If I assume it is a pump or any motor, so I should need some space to fix some other parts within this. But I need some space. This is called knockout activity. Knockout nothing but this is the knockout activity. Once you have poured, so you will take out the sandbox. So whatever the sand, the mold which is around the part, the removal process, sand removal process is nothing but knockout. Now sand is removed. Now it is going to be a cold process. So based on the shape or whatever they want, they will do it here. Yeah. If you see here, while putting the two, top and the bottom side of the pattern, he used a piece by using ropes and he has put it inside the pattern. This is that sand. So after removing the sand from this part, there is a cavity created. Cavity is nothing but the hollow space. Okay, after removing, it will look like this. So from here also we have a hollow, and from here also we have a hollow. Then after this, the casting will go for machining activity. So if we want to go for a threading in this side, maybe it is in a pump, if I'm not wrong. Okay. Yeah. Hope you have understood uh, the casting manufacturing process. Let us come back to the presentation. So as I explained, the pattern. Yeah, my screen is visible now. So as I explained in first pattern, he has made the wooden pattern. Then core, which is nothing but the core box which he has created. Then he has used a sand to create the mold. He used a mold making process. Mold is nothing but the shape which we required by using the pattern. Then we poured the molten metal. Then we do stripping is nothing but sometimes they do use some sticks or any other piece of metal to see the metal is processed. Then knockout is nothing but removing of sand once the liquid molten metal is solidified. Then decoring. Decoring is nothing but which he has done last. So taking out of the core inside the piece. Then sand reclamation. Sand reclamation in the sense, once they use that sand, it become hardened. So again, what they do is by applying thermal heat, temperature, they recycle it. So that by heating the sand with high degree temperatures, around 1300 degrees temperatures, whatever the resins, which means resin is nothing but it is a kind of a gum to hold the sand particles together. The resins get evaporated. Again, the same sand we can reuse it. Okay. So prior to that, we have in the furnace section, we have various other operations also, sub operations. We have charging, melting, slagging, refining, tapping, and also furnace maintenance. Charging is nothing but charging the furnace, like you are feeding the scrap metal to the furnace. Then melting, slagging is nothing but the waste which is forms over the furnace top. Then refining, we use some other metals to refine the metal. Tapping is also same kind of activity. Then we do furnace maintenance. So then in the fettling shop, in fettling, what will happen? Whatever the runners for pouring metal, he has used runners. So they will cut out all this excess pieces or the extra metal which is around the part and all. They will do in the fettling shop. Basically, here they do cutting, grinding, etc. Cutting may be do by big grinding wheels, or sometimes they do gas cutting as well. Okay, these are the various activities which will happen in the foundry. After this part, then it will go for machining. So where they do cold process for giving any surface finishing, or by creating a flange and giving flange holes to the flanges, etc., etc. Okay. Okay. For now, I'm stopping here. We have less than a minute. Maybe tomorrow we can continue this topic. Any questions on this foundry process?
Tomorrow morning is class there, sir. Evening, sir.